Welcome to our second video about three-dimensional vectors. Today we're going to talk about component form and magnitude of 3D vectors. Just like two-dimensional vectors, we can indicate a vector using our pointy brackets, our x, y, and z, similar to how a point is. With vectors, again, it is kind of hard to draw in your three-dimensional space, but this black vector is a vector in standard position, meaning that its initial point is at 0, 0, and then its terminal point is anywhere in the universe. But just like with before, vectors we can pick up and move wherever we want. Just depends on what we need them for. Pointy brackets are a very common way of describing vectors, but we can also describe vectors using the standard unit vectors. Since we have a third component z, we're going to have a third standard unit vector, which is k. Now be careful. When you write a vector in terms of standard units vector, this is not a unit vector. It does not measure 1. And we'll talk about that a little bit more later, but that was a common misconception that some people were having. A standard unit vector is just a different way of expressing the component form of a vector. So this vector 2, negative 4, 5 is the same as saying 2i minus 4j plus 5k. These are equivalent forms of the same vector. Neither one of these is a unit vector. We'll talk about that later. So let's look at a graph. Again, I'm not going to really grade you on drawing them by hand, but I do expect you to be able to recognize them. Because again, it can be challenging. So follow the dotted lines. Your vector is at negative 2. So that means you're going back 2 on the x. So here's your x. So you're going back 2, back 2. This one goes forward 2, so not B. This one also goes forward 2, so not D. So we're between A and C. Then it says we go up 4. Now it's not really up 4, remember, because it's the y value. So in the y direction, you're going 4. 1, 2, 3, 4. 1, 2, 3, 4. So both of those are good. And then we're going up 3, the vertical component of 3. So up 1, 2, 3. This one is going down 3. So this one, A, would be our correct answer here. So let's do some just thinking. Find the component form of a vector with the initial point. Remember, that's where you start at here, and a terminal point ending here. That's your arrow. So we start here and we end here. So this is where we kind of think, how do we get from point A to point B? If I start at 3 and go to 1, I'm going down 2. If I start at negative 2 and go to positive 5, I'm going up, so positive 7. And then if I start at negative 1 and I go to negative 3, I'm getting smaller. I'm also going down 2. Double check yourself. 3 to 1, you're going down 2. Negative 2 to positive 5, you're going up 7. And then negative 1 to positive 3, you're going, negative 3, you're going down 2. So that was question 1. Now it says express the vector using standard unit vectors. That does not mean a unit vector. That means the I, J, K. So you literally write the same thing, but instead you write I, J, K. Find the magnitude of the vector. If you recall, magnitude is just Pythagorean theorem, right? Since we have a third component, we're just going to have a third square. So you're going to have square root of negative 2 squared plus 7 squared plus negative 2. And then you can bust out your calculator or try to do some mental math. Again, always follow the directions of your problem. If it says to reduce your radicals and things like that, then make sure you do that. If not, You can express it as a decimal or do whatever you want. Just make sure you're always following directions. So the magnitude of this vector is the square root of 57, which does not reduce. So then it says find the unit vector. Okay, unit vector is a vector with a magnitude of 1. So this vector has a magnitude of 57, which is not 1. We have to try to make it be 1. And the easiest way to make it be 1 and maintain the same direction and the same angle that it makes with the axis and all that kind of stuff is to take the original vector, which we found up here, negative 2, 7, negative 2, and then divide it or multiply by 1 over its magnitude. When you do this, you are scaling down your vector to now make it have a magnitude of 1. It has the same direction, it has the same angle with the axis. It's just now 1 instead of the square root of 57. You're basically taking the square root of 57 and dividing by the square root of 57. So then you can be a good math student if you would like and rationalize your denominator. This one turns out pretty simple because none of these are divisible by 57. And there you have it, a unit vector, a vector with a magnitude of 1. Feel free to rewind, ask any questions that you need, and work on your practice problems. Have a great day, and make good choices.